Thanks for joining me here at Math Rocks with Mr. Cox. We're going to be looking today at how to expand upon an idea that you already know about, a simple equation like this where you would add 5 to both sides and then divide by 2. But what we're going to be looking at instead is, what if it wasn't an equal sign, but what if it was an inequality? How would that change our answer? And also, what if we did the same thing where we add an inequality, but we also add absolute value? So these are the two ideas that we're going to be looking at today. So if you want to find out more, stick around and find out. Let's get it on! Before we dive in to see how you actually solve equations with inequalities, let's just take a look at how you would actually mark it on a number line, because what's going to happen is our answers are going to look a little bit different. So we're used to getting answers like this where x equals 2, and that's just simply an answer. There's only one answer and it's 2. So how we would label that on a number line is we go to 2 and we would actually just put a dot there. And that would be it. That would be our one answer. But what if instead it was x is greater than or equal to 2, which means we now have more than one possible answer. So for instance, 2 would fit the bill, 3 would fit the bill, so would 4, 5, etc., all the way down the line. So anything 2 or bigger would work. And so we can't just put a series of dots. That would get a little redundant. So there's an easier way, and that is this. Because it includes 2, we're going to go to 2 on the number line, and usually I just go straight right above it here. I'm going to put a dot because it does include 2, and then I'm going to draw an arrow this way, which indicates any number that's greater than or equal to 2 would work. Well, what if it didn't include the equal sign and it was everything that was greater than 2, but not including 2? So for instance, it could be like 2.0001, it could be 3, could be 7, could be a lot of different numbers here. So the idea is it could be just slightly above 2, but not hitting 2. So what we do is, instead of having a closed circle, we have an open circle at 2. So I'm going to go to 2 right above it, put an open circle. So that means it includes everything but not 2. So it gets really close to 2, and then everything bigger than it. And likewise, what would happen is, what if it was less than 2? We do the same thing. We go to 2, put an open circle because it does not include 2, and this time we go actually the other direction. So that's what's going to happen here is when we get our answers is, it's not going to be just one answer like 2, but it's going to be a whole series of numbers that could actually make our equation true. So now let's take a look, how would we actually do this with actual equations? And the way to do it is actually just treat it like it's an equal sign. So just pretend that's an equal sign right there, even though it's not. So we can do what we've always done, which would be add 5 to both sides. So 7 plus 5 is 12. So now I get 2x is greater than 12. And then we can divide by 2, like we always have. And 12 divided by 2 is 6. So we get x is greater than 6. So these would be numbers like, not 6, but maybe 6.0001, and then it could be 7, it could be 8, etc., etc., etc. So what I'm going to do is I have to make up my own number line down here, and I'm just going to go ahead and put in a 0 so we have kind of a reference point. And this isn't really to scale, but I'm going to put 6 over here and perhaps 12 over here. So I'm just putting a few in other numbers, but I don't have to put them all in. And then I'm going to go to 6, and since it's not going to include 6, remember we have to do an open circle there. And we want to do everything that's bigger than 6. So that would be everything to the right of that open circle. So that's how we would actually do it on the number line right here. Let's take a look at a different problem. I'm going to go and switch over to green. Same idea, just treat this as an equal sign. So 3 times 2x when we do our distributive property would be 6x. And 3 times negative 3 is negative 9. We have greater than or equal to 8x plus 15. And once again, we're going to treat this just like we would any other equation. So we're going to go ahead and add 9 to both sides. 15 plus 9 is 24. So I get 6x greater than or equal to 8x plus 24. Then we're going to go ahead and we're going to go and subtract 8x on both sides. So I subtract 8x on both sides. I get negative 2x is greater than or equal to 24. And here is where a slight change is going to happen. We're going to go ahead and divide by negative 2 on both sides. But what we want to do is, any time that we multiply or divide by a negative number, like we are right here, we are dividing by a negative number, in this case negative 2, we're actually going to take this sign and we're going to reverse it. So when we do our division, we wind up with x, and then we're going to reverse it so we get less than or equal to, and then 24 divided by -2 would be -12. So in this case, it's going to be x is less than or equal to -12. I'm going to go ahead and get my number line going here. Here is my 0. I'm going to put my -12 over here. I'm going to go ahead and throw in a 12 over here. So I have a number line. Once again, I don't need all the numbers here, but I'm going to go here to where -12 is, and because it includes equals, I'm going to put a closed circle, and then I'm going to do everything to the left of it. So anything less than that would work. So for instance, -13 would work, -14, -15, etc., etc. And you can actually plug it in here, and you would actually see that it does make the equation true.
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show.
Finally, let's go ahead now and take a look at how we would deal with absolute value with inequalities. So this is a really simple one right here where it's already set up and good to go. And so let's just think of some numbers that would make this equation true. So I need the absolute value, which means the distance away from 0. I need it to be greater than 3. So here are some numbers that would work. 4 would work because the absolute value of 4 is 4, and that's greater than 3. 5 would work. 6 would work. 7, etc., etc., etc. So anything that would be 4 or higher, or in this case, you could do, for instance, you could do 3.000001. So anything slightly bigger than 3 or higher would work. Well, that's not all that would work. We can also do this. What about negative numbers? What if I did -4? Would that work? Well, the absolute value of -4 is 4, and 4 is greater than 3. So you know what? That would work too. So would -5, because the absolute value of -5 is 5, and that would be greater than 3. And so would -6, etc., etc., etc. And in fact, just like over here, if we had -3.00001, when we absolute value that, we get a positive 3.0001, which is greater than 3. So we're going to have actually two different areas of the number line here. So what I'm going to do here is I'm going to go here, I'm going to put a 0. I'm going to go ahead and I'm going to put a 3 over here, and I'm going to put a -3 over here. And now what we're going to do is we're going to do anything that's going to be greater than 3, but it can include 3. So I'm going to have an open circle, and that's going to be going this direction. So any of these numbers would work. So that's the 3, 4, I'm sorry, not 3, but 4, 5, 6, 7, 8, etc., etc. And likewise, anything less than -3 would work too. So that's going to go this direction. So really, almost any number would work here except for the numbers in between -3 and 3. And let's go ahead now and take a look at a second variety here, a little more complicated. So how are we going to get these two different sets of answers is going to work like this. Number one, we're just going to go ahead and ignore the absolute value and write out 2x plus 5 greater than or equal to 9. So that's going to be one equation, and we're going to get an answer here in a minute. And then we're going to do a second equation that's going to look very similar, 2x plus 5. So the 2x plus 5 doesn't change, but as over here, what we want to do is we want to come up with some sort of way of doing it. And so what we're going to do is we're going to reverse the sign, kind of like what's going on over here, because to get these answers, we have to do everything less than -3. So it would be like less than -3. So I'm going to reverse this sign, and instead of being like over here, instead of being a 3, it's everything that's going to be less than -3. So it's going to be less than or equal to -9. So we reverse the sign, and then we also change the number from positive to negative. And then from here, what we're going to do is just solve each equation. So I'm going to subtract 5 and subtract 5. So I get 2x greater than or equal to 4. I'm going to divide by 2. So now I get x greater than or equal to 2. Over here, I'm going to go ahead and I'm going to subtract 5 on both sides. And when I do that, just to make sure you don't actually do this wrong, -9 minus 5 would be -14. So 2x is less than or equal to -14. And now when we divide by 2, we get x is less than or equal to -7. So just notice that we're not going to necessarily get the same numbers here. One was 2, one was -7. Where over here, if I actually had, I would have one of them would have been x is less than or equal to -3, What if x is greater than 3? These are the same numbers, one's positive, one's negative, but that doesn't usually happen when you're solving equations with inequalities and absolute value. So now let's go ahead and actually put this on the number line. I'm going to put 0 here as just kind of a reference point. I've got 2 over here. I've got -7 over here. So anything greater than or equal to 2 would be a closed circle going to the right. And this would be at -7, closed circle, because it's an equals, and it's going to be everything less than. So this is how we would symbolize it on our number line. So that's it. That's how you deal with inequalities and absolute value. Hope you got a lot out of this lesson, and hope to see you again soon. Thanks for watching.